Welcome back to another YouTube Tuesday. My name is Derek, and today we're going to be going over another channel that was recommended by one of you guys. And that channel is Paul Daniels. Now, if one of the things that you do is MacBook repairs, you've most definitely heard of Paul Daniels. Apart from the fact that he has really educational content, he also has software that he continues to update so that techs like you can repair MacBooks. On YouTube, he has over 40,000 subscribers with over 400 videos. Today, we're going to be taking a look at one of his more recent videos so that you can get an idea of what to expect from watching his videos. So let's get into his video.
Welcome back everyone. Well, today we have a 2485, which is quite the beast of a MacBook, and this one's had a battery replacement, and after the battery replacement the MagSafe light would blink on, blink off, blink off. Yeah, a bit of a, do we have a battery fault here or do we have something else at fault? And I can feel the batteries flapping around. That's not a good sign. Alright, well, let's get it open, have a look, and see what we can do.
If a battery is flopping around inside, it can definitely affect the little flex cables that connect the cells. So I highly recommend anytime you do a battery replacement that you adhere it in one way or another. Whether that's using the original adhesive if you kept it intact, or something as simple as using some Tessa tape.
Let's see, everything looks average enough. At least the nice thing is I don't think you have to take the boards out for these ones. So the pull strips there. What's flapping around then? It's these middle packs. They're flapping around. Why? There's no adhesive under them or something. That's weird. So they've got pull tabs on these, but not on these. That one doesn't have a pull tab either. That's not a good thing really, because what happens is when these flap around and all that, they eventually fatigue the connections a little bit. I'm trying to think. Let's see if USB-C gives us anything interesting. 20 volts. Reset. 20 volts, reset. We're resetting only at about 1.4. That's interesting, and now we're holding. Let's see if this steps up. Let's see if this ramps up okay. So it looks like it's trying to get started and then it just crashes out. Okay, so that's MagSafe. That's USB-C. We'll try a genuine Apple MagSafe now. The current is just haywire. Okay, so we've settled down to 400, 300. Well, we're going the wrong direction. This one's a weird one. We'll have a look at what's been done with the battery. Let's see, the screws are chewed out. That's not good. It could be that it's just an incompatible battery.
A lot of the time when a device goes completely dead, you may just be inclined to replace the battery. And sometimes that's the solution, but other times it's something else that caused the original battery to drain. I have a feeling like there's going to be an issue with the logic board to where this battery probably didn't even need to be replaced in the first place. Maybe it was swollen, who knows, but there's probably something else going on besides just the battery.
Although what bothers me here is that there's some lifting up of the adhesive here. That shouldn't normally happen. So there's no reason to touch any of that. So what did they do? I see what they've done. Right, they have torn away this flex a little bit from the board. Although it doesn't look like it should be enough. For some reason they pulled up that, and I don't really know why. Because even if this one was disconnected, that whole set there, single group. So if we look at this board, so what do we got? NC, bat, ground. So yeah, that's, even though it is messed up a little bit, we basically just have the battery and ground and nothing else. The actual signal lines come in on the flex.
So those of you that were wondering, this board view software that he is using is his Flex BV software that he continues to update as he has more information to put onto it. So it's definitely highly recommended to have some board view software if you're going to be working on logic boards. And this is a really good one to have. If you followed Louis Rossmann for any time, you would hear a lot about Paul Daniels. So
we'll test these, see what they look like. 5, 5, 9, 1, 2, and right, that's 5, 7, 3, 8, versus 5.9. Doesn't seem like a huge difference, but yeah, we'll see how we go. And the last one here, 5.3. Okay, that's about right. Basically because these are clock and data, so you'd expect them to be pretty close, although the diode mode, interestingly enough, does show there is a little bit of a difference between the two of them. Let's see if this runs perfectly fine with MagSafe 3 only. Okay, what you can hear there is a bit of a problem. I'm just not sure whether the fans are running because the battery is missing or there's another issue that we've missed. Yeah, there's a little... that should actually be able to run off MagSafe 3. Oh, we're going to take the board out and have a look. We've got a bit of a bend on this connector here. You can see it in the reflection. It's kind of unexpected. No real dust or anything down here. But I can immediately see there's some corrosion down here by the base of the CPU area. It's not unusual. Let's have a closer look. See what we're dealing with. Alright, yeah, that's some well and truly advanced corrosion going on there. Put a little pink dot there to let me know I spotted something there. And we're going to have a look at the rest of the board. Because if there's that one, then there's possibly more. It does look like a...
That's a really good idea. I've never really thought about doing that. In marking where you found an issue so that you can return there later as you scour the rest of the board. I think I'm going to start doing that from now on.
A bug event. Looks like that's probably the only one. So we'll get this CPU barrier removed and then we'll have a look. We don't need a lot of heat to get this up, but I want to try not mess it up too much. Okay, so I wonder what that part does. Let's have a look under the board view and schematic. So there's UD102. And lo and behold, it's part of the charging system. Alright, so it looks like it's basically a level shifter. Over here we can see we've got 1.2 volts. And over here we see we're talking with 1.8 volts. So basically it's just a translation circuit that allows lower voltage signals to communicate with higher voltage signals back and forth. Let's see where we can find these things. Okay, frustratingly we've got a situation where it's all just modern boards like 2098, 2443, 2773, 2100. This here could have been the closest one. That's for the new model M2 chip in a 2337 body. 2100 is this board. 2382, I don't have any of those. So yeah, we've got a problem here where we just don't have this part. We've got this H1 marking here. Now we'll get our 2016. Okay, so there are definitely different markings on the chips. Now it could be a few reasons for that, but it's enough for me to not want to transfer the parts. Realistically, I'd be very surprised if there was a difference, but I just don't want to risk it on this machine. One of those things, if you get it wrong, it's going to be very wrong. Let's dry brush that away. It looks like it's pretty crusty. Now it's going to be a little bit tricky to get it off at this area. It's quite a heatsink area. To give it a little...
Not only is that area a heatsink area because of the CPU, but you're also working right next to the CPU. So it's definitely an area where you have to be fairly cautious so you don't mess things up.
A little bit of a hand. I'm going to drop a tiny amount of flux if I can help it. Those adhesive pads don't appreciate that, so we'll just take them off. We can put them back later. Alright, let's try that again. That's what I was hoping not to really see. So the problem is that the corrosion has actually eaten into the board. So whatever it was, it wicked very nicely underneath the chip and started taking out the pads. We'll clean that up. Fingers crossed we might have some success still. It's going to be a little bit hot for a bit. It
looks like the pads are still there. They are definitely heavily oxidized from the corrosion. So the way to get rid of that is to carefully scrape at it with something like a scalpel so that you can then take some solder and get it to stick to it. What you'll want to use is a lot of flux here, because the flux acts kind of like a cleaning agent, as it not only does it prevent oxidation from occurring while soldering, it also kind of cleans the oxidation when heat is applied. So I'd say that there's a good chance that he's going to be able to get these pads cleared and accepting solder. If he can't, luckily the traces are right there. It's going to be very simple. It's small. It's still small, but it's going to be simple to run jumpers and create new pads so that you can put a chip back on. But I think he's going to be able to get these pads all fixed up, just given what they look like right now.
It's sitting there and chewing for a bit by the looks of it. This resistor down here, you can actually see that there's a bit of corrosion under the pads here. I'm gonna have to make a choice about that. This resistor here is half on. It's one of our 3K3 pull-ups, so this here is a 3-volt rail pulling up the signal. So yeah, I think I might remove that. See how it goes when I do the resoldering rework in this area. Unfortunately, I have to add a bit more flux, and then we're going to come in with a soldering iron and a bunch of solder to try and clean up this area. Yeah, see how the resistor just basically came off dead easy. I didn't even have to try to get that off. It just willingly let go. So that's what I was talking about, being a concern of it. It's a good thing we found that, because we could have replaced the chip. Thought everything was okay, and then a few weeks later it would have let go. Or even worse, it might have kept holding on, but the resistance would have changed sufficiently to create some very bizarre effects. Bad signaling, bad protocol timings, things like that. And it would have actually been quite difficult to diagnose. I do wonder whether this could explain that difference in the data lines that I saw when I was testing. Fortunately, the pads are still there, so that's a blessing. Again, a little bit of flux. Once more, hit it with some solder.
Now you can see how they're all pilled up nicely. They're receiving plenty of solder. Now, one of the reasons you definitely need to have some type of board view when working on these is, or not necessarily board view, but a schematic, is if you knock off a resistor, you need to know what kind of resistor it is. You can't just grab any resistor. You can't just grab any chip like he's talking about. So having the knowledge, having the schematic, having the board view really helps, and it's kind of necessary if you're going to be getting into logic board repair. Now, if I remember right, the cost of the software isn't crazy. I think last I looked, you could easily make up the difference in the cost for the software with one repair. So definitely check that out if that's something that you're interested in getting into.
And once more, clean it up. A few days later. So I managed to get myself a iCloud locked mainboard from eBay for this machine. Very fortunate. It just happened to be there at the right time at the right price. And I'd also like to thank Pedro for sending through a couple of the parts that we need. He took them off one of his boards because there's about 6 or 7 of these particular chips on each board. So thank you again, Pedro. The nice thing is, because Pedro has given me these, it means I don't have to touch this board, which means I can now use this for diode mode measurements and things like that, which means we can have some better data on open board data. Anyway, let's get to it, get this replaced, and hopefully the machine works fine. Interestingly, these ones have the VD mark on them, and these are H1 marked. Okay. Well, that's it. It could have been that I would have been able to replace them with the ones I could get from other boards, but I just didn't want to take that risk. You can see which ones Pedro has. Okay, these are also VDs. Interesting. Yeah, these have actually had the pad ripped off, I think. Alright, so this one's more intact, so we're going to use this one. Yeah, they're a particularly difficult chip to remove simply because of the position next to the CPU. Those pads, actually that back one there, just got to fluff them up a little bit. Okay, they're fluffed. It's preheating this whole area. This is only at 270, so it's very low. Remember, we do have to put that resistor back too.
Preheating is definitely something that you need to be doing if you're working on a large logic board. You don't want to shock the area with too much heat, causing expansion, causing things to move around. But when you go in with a lot of heat, you need to protect things like the CPU. You really don't want to be messing with it. And that's one of the reasons why I think he's being very meticulous about how much flux he's using, because he really doesn't want that flux to run around the board and potentially get somewhere. Because flux, even though a lot of flux is considered no clean flux, it does tend to assist in the kind of oxidation of components over time, and it could potentially cause issues if left on the board. It really depends on the flux. It really depends on a lot of things. But if you don't know what you're doing, things can definitely go wrong if you apply too much heat without the proper heat sink and protection. So he's shielding everything that's really important so that the heat doesn't get directly on it. Of course, things are going to get hot, but not hot enough if you know what you're doing to cause any of the solder to melt, causing issues with the CPU.
Okay, and that is down. I should have had the resistor ready. One 3K3 resistor. And that's done. Very good. Yeah, I think we'll just have to accept that as it is. Fingers crossed things go well. Lovely. Here goes with the testing. Let's hope that the correlation between the battery issues and that level shifter are actually related to each other. MagSafe in, 20 volts. I want to see that charge rate go up. Looking good, but the fans are still spinning a bit fast, so may not have properly fixed it. Yeah, it's interesting. The fan actually settled down now. This charge rate still is not picking up though, unless that pack is fully charged. I doubt it.
Now, this is something that I see a lot of, and I still don't know what it is. What is it that causes the fan to kick on really high and then all of a sudden start working properly? It'll like the first 30 seconds, sometimes things kick on really high, even though I'm just curious if anyone out there knows what that is. Whenever I've gone through the process of making sure that everything's properly connected, everything's properly, and everything is done in the proper order, when I go to turn it on, the fan kicks on really high for 30 seconds or something, then it stops and it goes back to normal. Let me know in the comments below.
No, it is not. It's indicating... Oh, there we go. Bit of patience. Oh, had me panicking there. First the fan won't stop spinning for a bit, and then we're not getting our proper charge rate, and now here we are, 4.6 amps. That's flat out, and we've still got a screen on. How is it drawing that much power from that pack? 5 amps, 20 volts. That's 100 watts. That pack's... well... oh no, that pretty much is full 96 watts coming out. 4.6 times 19.7. Hooey, that was a fun one. I mean, it wasn't an overly complicated job, but it was still a fun one. It was nice to have that correlation, or causation I should rather say, between where we found that little bit of corrosion just down below the CPU on the bottom and the fact that the battery wasn't being properly detected and charged. Very happy about that. And of course, we did have to spend a fair bit of money to get ourselves a donor board. And again, thank you very much to Pedro for sending through those little components, and which means now we can use that donor board to populate all the diode mode values and things like that to help other people out there with the open board data system. Thank you very much for watching. I'll see you all next time. Till then, you all take care.
Alright, so there we go. Hopefully you were able to grasp why he was recommended. Go on over to his channel and check out his other 400 videos and see if there's something that's going to help you learn how to fix other devices. If there's a channel that you'd like to recommend, leave it in the comments below. Thanks a ton for watching. We'll see you tomorrow for another video.